Hello guys and welcome back to my channel. I'm sorry for my voice, but I had the cold and it's not completely over. I have waited a long time for this moment. Right after I did the initial hardware modification to obtain 250 milliwatts on the Crossfire Micro transmitter, I was thinking how awesome would be to make it reach 500 milliwatts. And how I thought about this, it's pretty simple. This little IC here, which is the RF amplifier, is produced in three flavors: 250 milliwatts, 500 milliwatts, and there is also another one for 1 watt. The 1 watt has a completely different matching network for the input and output, and it would mean that the modifications needed for it to work would be too extensive, and it's just not worth the hassle to do it. But the 500 milliwatts IC has almost no differences between the 200 milliwatts amplifier, except the power supply, which is different because the 200 milliwatts one works on 3.3 or 5 volts. The 500 milliwatts works only on 5 volts. The Crossfire uses 3.3 volts, so we have to apply an exterior power supply to feed the IC with 5 volts. I will use some sort of little switching regulator for that, small enough to put it inside the case, and just run a wire to feed 5 volt here. What do we need to do? First, we need to change the IC from this BGA7124, which is the 200 milliwatts version of the IC, and install a new BGA7127, which is the 500 milliwatts amplifier. So for that I will use my hot air gun to take this out. I already worked here, so this IC was taken out. You will see here a pad that's ripped, but that's not a problem because this pad here, this pin here and this pin here are not connected, so we don't have to worry about that. Apply some flux over the area and hitting the board from a distance, but from my experience this PCB will need a lot of heat to reach the desired temperature to melt the solder. So we took out the IC using the solder wick to clean the pads, some solder to the pads, I managed to kill that pad also, but as I told you from before, those two exterior pads, this one and this one, were not connected, so I am not worried about that. Now cleaning a bit. Here are the new IC I will be using. Now hitting the board again. placing a part and some more flux. I will remove this inductor here. Now I will take the inductor and solder it like that. I will clean this pad here a bit. Now, for you guys to understand what I did, this pad here on the PCB is the source of the 3.3 volt supply. So we will need to feed on this inductor here 5 volt and not mess with this 3.3 volt source from the rest of the PCB. I attempted to power the RF amplifier from a 5 volt supply. It worked, but it wasn't stable enough. The only thing that could induce instability in the system was the bias network. And on this particular IC, here we have one resistor of 1.8 ohms, which on the 200 milliwatts amplifier is recommended to be 0 ohms. So TBS decided not to place one 0 ohm resistor, but rather just use a straight connection between this section here to this section. So this is the schematic, and as you can see, this resistor is not physically on the PCB, so we will have to add it. Off camera I did something. If you look down here, you can see that I scraped this section was the trace, or the copper trace. So in fact we broke the connection between this pin and this pin of the cap here, this cap and this inductor, and right here we will solder that 1.8 ohms resistor. So let's get to work. So I managed to put here a blob of solder to connect those two caps, and I also put here a little blob of solder, because what I want to do is just take the 1.8 ohms resistor and hit the area and just place the resistor here, but in the same time be very careful not to touch the ground section of the two caps, just like this. Just like that. And now some of you will kill me because I'm using such a big tip, but I promise you I will change my soldering iron with a better one. But this one is the only one that keeps my temperature okay. So I just retouched that one. I'm gonna hold it like this and attempt to touch the other side. And I did it. As you can see, there is solder there. Clean this area a bit, just to be sure that we did a great job. So essentially this resistor is just in series from here to all this section here. I'm just taking my multimeter and probing these two sides. And I'm seeing 1.8, 1.9 ohms, which is pretty close. Remove this inductor and place it parallel with the board, because my initial idea was not too great. So now this inductor, instead of going to this pad, which is 3.3 volt, now it goes from this pin, which is connected to this side, goes nowhere, so I can actually solder one wire to this side of the inductor. I will not go into very much details, because I don't know how many of you are actually trained in the radio frequency or not, but those of you who are, I am pretty sure you got the idea of what's happening here. Now I will just touch this wire there, take my power supply leads, connecting the negative to the USB housing, because that's ground, and here I will just attach this from my power supply, and setting my power supply to 5 volt.
Welcome to OpenTX.
And I already see on my spectrum analyzer around 34 dB of channel power. And if we subtract my input attenuator, which is around 7 dB, we actually have 27 dBm. And if we go here, which is dB to power ratio converter, and we go to 27, I have exactly 500 milliwatts. The amplifier is very stable. I see no spurious oscillations or anything related to that. I'm happy about the result. The amplifier gets a little bit toasty, but it was expected. Nothing out of the ordinary. It draws around 200 milliamps at 5 volt. Let's see if I change the settings in the firmware to 100 milliwatts. Yeah, so I see only 1 dB down in actual output power, and that means 26 dB, 400 milliwatts. And if I set it on 25 milliwatts, I see around 19 dB of output power. And if we go to 19, actually it's 19.5, and that's 90 milliwatts. So now instead of a 200 milliwatts Crossfire Micro Tx, you have 500 milliwatts. Don't get worried about the fact that it will get hotter. This is the 5 volt supply I will be using to power the RF amplifier. It's a switching regulator similar to Pololou or other brands. Choose the most little ones. If they are rated for 500 milliamperes or more, they are perfect for this situation. You have to choose one that can accept 3S if you are using a 3S battery on your transmitter. And I will solder it here. take the metal can, and if you look closely here, I cut out a little bit of the metal and my wire comes out through that cutout. I will hold the metal can down, heat up this section here and also this section over here. I have installed a double-sided tape, which I will remove now. And stick it on the LED and USB board down there. Press it a bit. It sits pretty nice there. And now our 5-volt line goes through here and enters the metal can through there. Now I will remove my temporary wires. I will just retouch them because I messed them up a bit. Cut my little wires, strip them, thin the leads. This ground one I stripped too much, so I will take the ground and I will solder it here. And take the input for my 5-volt regulator and solder it to the battery plus connection. Route them the best you can. And now I have my connections going to the 5-volt switching regulator, and the output goes to the other side and enters the metal can to power the RF amplifier. Next I will connect this straight to the transmitter and see how the output performs. This is the bandwidth Crossfire uses. Let's power on the transmitter now.
Welcome to OpenTX.
And as you can see, the Crossfire jumps all over this bandwidth. And if we want to see the actual RF power, we max hold the entire bandwidth and over a period of time, when the spectrum analyzer catches all the jumps the Crossfire did, it will show us the channel power, which is right now showing 33.89, around 34. And keeping in mind that I have 6 to 7 dB attenuation on the input, this means that we have somewhere around 27 dB, which means around 500 milliwatts. This was a tutorial on how to modify your Crossfire micro transmitter from being 200 milliwatts to 500 milliwatts. I have to say I would not recommend this mod to a beginner, but if you are confident on your soldering skills, then go on and do this mod, because 500 milliwatts is enough power for you to even do long ranges. Again, I hope you understand that if you mess with anything on the PCB, your warranty will be void for sure. Parts needed for this mod: one is the RF amplifier, which is a BGA7127, and the 1.8 ohm resistor, but I will leave all the details in the description. If you want to support me, please subscribe to my channel, share, like. I think these are the things I wanted to say at the end. Thank you again, and see you next time. Bye.